So this video is going to build on the previous one, which describes how the electrons are arranged around an atom. From that, the bonds are arranged in certain directions, which gives the molecule an overall shape or geometry. So if the groups of electrons have no lone pairs in them, then basically the molecular geometry is exactly the same as the electronic geometry. So the electronic geometry, which we're going to leave in green here, I'm going to write in pink what the molecular geometry is. It's also linear, okay? Because when we look at the arrangement of the oxygen atoms, not the electrons, but the atoms bonded to carbon, we see two on each side opposite in a line. All right, so in formaldehyde, when we look at formaldehyde and we look at the atoms around the carbon, we can see three atoms at more or less the corners of a triangle, so it's also trigonal planar. Now this is where it becomes different. So there's three groups of electrons, okay? And remember, I drew this down here like this. And now when we look at the atoms only in sulfur dioxide, and let's just go ahead and put the double bond in here, and the Lewis structure and all that stuff. The angle is 120 degrees, but it is bent or angular. So either word would be acceptable. Angular or bent. Just pick one. Don't use both words. And so this is a case where if you have lone pairs, then the name of the electronic geometry is not going to be the same as the molecular geometry. However, if you're just guessing, half the time you'll be right, because half the time the molecular and electronic geometries will be the same. And here again, no lone pairs, so it turns out that the molecular geometry is tetrahedral. All right, now this is not the same. All right, so if we're going to look at ammonia, so just imagine this is a nitrogen here, and this is a lone pair up on top. If you do that, then you can see that what's remaining is the atom nitrogen, and then three hydrogens form a trigonal-based pyramid. It's not flat, because all these hydrogens are below the carbon. So this is trigonal, which means three, but it's not a plane, it's a pyramid. And then finally, if you imagine water, it's just like methane, except now in the middle you have an oxygen and you have two lone pairs. So let's imagine we can't see these two hydrogen atoms. Then you get an angle of 109.5 bent. So angular or bent. (109). Now actually less than 109.5 degrees. So now remember, the reason it's less than 109.5 degrees is if we have two lone pairs, it's pushing the other bonds together, so their angle becomes less than 109.5 degrees. Angular bent here, less than 120 degrees. Okay? Because again, the lone pair is pushing the bonds together. Okay, that's it for molecular geometry.